What you just saw is the first launch attempt of my self-made model rocket. Unfortunately, there has been an failure, and I am going to talk about it today. So in this video, I'm going to briefly introduce my personal model rocket project and talk about the problems behind this failure and how I am planning to solve these problems in the following months. So I started this project last September, and at first it's because I was watching some model rocket videos on Bilibili, and I thought it's really cool, but it's not that hard. So I thought I could do it on my own, and I started this project. Honestly, I have been spending most of the time working on motor designs and tests because that is the most important part of this project. And basically that is the only thing that I've been working on from September to about January. And I am planning to do another separate video about motors, about motor design and testing, because that is what makes this project work. And there are really a lot to talk about it. I have been learning and improving the designs and keep on researching along the way. So there have been silly and ridiculous designs in the past, but also the parts have been improved a lot in the past few months, and so does the manufacturing process. For example, in the past I used to use these kind of alcohol burners to cook the fuel, but they turned out to be very dangerous and highly uncontrollable, and it messed up a lot of things. So I bought a stove that I can control the temperature and get feedback, so it makes everything much more reliable, convenient, and controllable, and I do not need to worry about my own safety that much anymore. But anyway, the overall aim of this project is to launch a entirely self-made model rocket, but the actual design of the model rocket has been changing a lot lately because mainly according to what time I have left to work on this project, because I also need to work on my studies as well. I used to set my goals as flying a gimbal motor model rocket, but it turns out that it is a little bit too time consuming for me, because if that's the case, I not only need to design my own motor, I need to design the gimbal system for the motor. So that plan got cancelled. So as for now, my goal for the rocket is to it should have a self-made motor that gives about 30 newtons of thrust, and it should be able to deploy a parachute electronically using servos and rubber bands instead to pop out the parachute instead of using explosives, because I am not an expert at explosives. I do not think that I have the time to work on it. So, and I definitely do not have the confidence that I can work well with it. So I chose to do it electronically, and also the rocket should be able to communicate live with the ground station so that I can get know of how high the rocket is flying during the launch. So there are four main parts in the rocket. The upper two parts, the parachute module and the electronics module. And also we have the motor and the motor holder. So first of all, the parachute and electronics. This is where the parachute is held. You can see that it is covered by this blue stuff, and here's the parachute. And in real case, I mean, when doing a launch, the parachute should have a rubber band folded behind it like this. So if I push it into here, if there's no cover, it will just fall out like this because of the rubber band. So there will be a cover at the outside to hold it during the launch. And it's nasty. And there's a servo in the electronics module that controls the that holds the cover, and when the chip inside detected that the rocket has flipped over to a given angle, it would tell the servo to unlock the cover, and the parachute would fall out. So this is the parachute module. As for the electronics module, we can see that here's a servo and here's another space for the batteries, which is apparently not here. And underneath these two stuff, there are a ESP32 chip that is meant to control all of these stuff, and there's a transmitter that communicates with the ground station, and there's also a MPU 6050 chip to the sensor to sense what angle the rocket is at, and to control the release of the parachute. And during the launch, it should look like this. So the next part is the motor. This is what a motor should look like. It looks a bit nasty because I had quite a hard time getting it off of the motor holder. It produces 33 newtons of thrust and works in over a period of 2.26 seconds. And it is 32 millimeters in diameter and 121 millimeters in length. These are the igniters used for this motor, self-made also. This is the already used one. You can see it looks disgusting. And this is a brand new, never used igniter. So inside of this is a nickel heating wire that heats up and ignites this little piece of KNSB fuel, the same material as the fuel used in the motor. So in the test, it should work well. And so here is what it looks like during the test run and what it should look like during the launch. It looks quite good, right? But obviously that's not the case in the launch. As for why, I would cover that later in the video. And so now this is the final part of the rocket, the motor holder. It's 3D printed, like the electronics and parachute module. It is designed using OpenRocket mainly for the shape of the wings. So the motor should go into the back of the holder like this. It fits quite well actually. So basically this is it. This is how the rocket looks like. Actually, I think it looks like the rocket in the Adventure of Tintin. Apparently, the motor hasn't produced enough thrust to let the rocket leave the launch pad. And there are a few possible reasons that I suspect should be responsible for this situation. The first reason is that the fuel inside is not burning in the right direction. So now we have two versions of our motor. The left one is a version with the outside igniter, and the right one is a version with a inside igniter. So the problem is this. if the igniter is inside of the motor and it is like at the furthest place from the nozzle possible, when this got ignited, it will ignite the fuel around it, right? So in this case, the fuel will start burning first radially and then outwardly. So it gives really a huge burning surface inside of the motor. But instead, if we are looking at what happens here with a outside igniter, so in this case, the igniter can be put into different places, right? So what I suspect is that what happened in the launch is that this igniter got put too close to the nozzle, like somewhere around here. So what happens is that when this got ignited, the fire of the igniter will ignite only the outer surface of the fuel. So it will only burn inwards like this, instead of burning radially as we want it to be. So if we compare these two, we can see that if this is the case, we have only this amount of burning surface. Well, if this is the case, we might get a whole lot more of burning surface, and burning surface is somewhat equivalent to the thrust. If we get greater burning surfaces, the thrust will be greater. So I guess that is what causing the problem. I did not put the igniter deep enough into the motor, and then the burning of the fuel has a too small a surface to create enough thrust. Yeah, and by the way, this is the version that got tested, and this is the version that is in the testing footage. So yeah, we can see the difference between the this one and this one. So that is a problem that I need to work on. And by the way, why didn't I use this version of motor on my rocket? Is because that you see that those two wires that are supposed to use to ignite this igniter, they need to be connected to a battery, right? But I figured out that the battery on board the rocket is not powerful enough to ignite it, and plus it will be extremely annoying to try to get those wires to be connected to the battery. So I just abandoned this design and tried this one instead, because it will be much easier to ignite, because you see the wires are outside, meaning that I can put the battery wherever I want. The second possible reason for this problem is that the KNSB fuel is taking up too many moisture. And so at this time of the year, Shanghai is extremely rainy and there's always a lot of moisture in the air. So it is really easy for a fuel like KNSB to get degraded. Well, anyway, I cannot say for sure which of the reasons has caused this problem, because I need to do further tests, but it could be both reasons. So anyway, there are still a lot of things that I can do now. First of all, I am going to put the outer igniter deeper into the motor, in which that it could let the motor burn radially instead of burning, inwards. And I am going to make another or possibly multiple test runs on the motor to see what can I do in order to make it work with an outer igniter. And also, the nozzle I think can be redesigned, because now it is undergoing really fast abrasion during launches and tests. So I can see that it has widened really a lot, and it will definitely have negative effects on its performance. So I am thinking of redesigning it, make it smaller, so that I can really push the motor to its limit and let it give all the thrust that it can give. And finally, I will take good care of the moisture problem during the manufacturing from now on. I have some desiccants on my to my hand now. These are the two, so I am going to find out some way to use them efficiently and abundantly during the coming up manufacturing of the motors. The second problem with the launch is this, the launch pad. Honestly, the only reason that it exists is that the launch pad needs to support these three guiding rails that holds the rocket upright when it is going upwards, but not with a very high velocity. I mean, the velocity is not high. It is not high enough to let the wings on the rocket to stabilize itself. But the problem is that, I mean, it is doing its job well. The rails are well supported, but the problem is that the rails themselves are too soft. You see, they can easily bend around like this. So what I think is causing a problem is that when during the launch, these three rails may gather together to pose friction on the rocket that is trying to fly upwards like this, or it is moving around and guiding the rocket to the wrong direction. So what I'm going to do is that during the next launch, I am going to change these tubes. Yeah, by the way, now I am using PPR tubes for the rail because they are easy to work with. They are cheap, and they are quite available around. So, but it turned out to be a mistake to use them. So in the next launch, I'm going to find harder materials and gonna use steel tubes, or at least aluminum ones that do not bend so easily and cause problems. And also the hose on the launch pad is not big enough because I am literally struggling to put those tubes into the launch pad. And also the design of the launch pad itself might be slightly altered based on how the results with the new igniter and motor comes out, because I might need to change or design a new way to install the igniters and keep them from falling out of the motors and causing another problem. Alright, so that is basically all that I have to say in this video. I hope you guys enjoyed it, and I will keep on working with it throughout this summer. I will see you guys in a few months.